Mercury is frequently characterized as a scorched, inert fragment, a dead rock baking in the sun's glare. Most of the time, Mercury is actually Earth's closest planetary neighbor, yet it remained the least understood body in the solar system for the majority of human history. From our perspective, studying it is like trying to photograph a subject standing in front of a searchlight. Because it orbits so close to the star, it appears only as a featureless silhouette lost in the solar glare. This visual barrier allowed simplified assumptions about the planet to persist for decades, leaving physical exploration as the only way to reveal the world behind the shadow. Reaching that world is an immense engineering challenge. Mercury travels faster than any planet, completing a full trip around the sun every 88 days, requiring any incoming spacecraft to reach incredible speeds just to catch up. Then there is the gravity. Approaching the inner solar system means falling directly into the sun's massive gravitational well. Without absolute precision, the sun's pull will simply snatch the probe and fling it into the star itself. These orbital mechanics are so unforgiving that we visited the Moon, Venus, and Mars decades before we could successfully place a mission in Mercury's vicinity. In 1973, NASA's Mariner 10 became the first mission to reach the planet. It used the gravity of Venus as a slingshot to redirect its path and slow its descent toward the sun. The first clear images showed a landscape of massive, jagged cliffs. Some reached heights of 3 kilometers and stretched for hundreds of kilometers across the crust. Geologists realized these cliffs were evidence of a shrinking planet. As Mercury's interior cooled, the entire world contracted, wrinkling its surface like the skin of a drying apple. More surprising was the detection of a magnetic field. Because Mercury is so small, researchers assumed its interior was a solid, frozen block of rock, but a magnetic field requires an actively flowing core. Mariner 10 proved Mercury was far more complex than a dead rock, but since the probe only performed brief flybys, it only saw 45% of the surface. The rest of the planet remained a mystery for another 30 years. In 2004, the Messenger mission began a grueling 7-year journey to finally achieve a permanent orbit. It required a series of 6 different planetary flybys just to bleed off enough speed to be captured by Mercury's gravity. This global map allowed scientists to measure the planet's contraction with high precision. They discovered that Mercury is shrinking 5 times faster than earlier data suggested. Messenger revealed Mercury's magnetic field is strangely off-center. The entire field shifted toward the North Pole, constantly buffeted by solar winds. This field is generated by a massive iron core, occupying 57% of the planet's volume, compared to Earth's 17%. At the poles, Messenger confirmed a final contradiction. Because Mercury spins with no axial tilt, the sun never reaches the bottom of certain deep craters. In these pockets of permanent shadow, huge deposits of frozen water have remained stable for billions of years. By maintaining a permanent presence in orbit, Messenger transformed our understanding of Mercury from a simple sun-scorched rock into a world of extreme internal activity and physical paradoxes. Among the most unusual features found by Messenger are hollows, strange depressions where the surface appears to be actively evaporating into space. The presence of these evaporating materials and ancient ice suggests that Mercury likely formed much further from the Sun, only to be pushed into its current lethal orbit by a massive gravitational disturbance. Today, Mercury exists as a planetary survivor, shaped entirely by its struggle to exist in the Sun's immediate proximity. Mercury's environment provides a direct look at stellar evolution. Over the next billion years, the Sun will expand, engulfing both Mercury and Venus. At that point, Earth will become the closest planet to the Sun, forced to endure the same radiation and extreme conditions we see on Mercury today. To study this process, the BepiColombo mission is currently en route. One of its objectives is to analyze the fresh crash crater left by the Messenger probe to see how the surface ages in real time. Mercury is no longer just a distant curiosity. It is a physical blueprint, showing us exactly what happens to a world when it becomes the closest neighbor to a mature